Here I'd like to find the angle in standard position of the vector shown below. Now, standard position angles are always measured relative to the positive x direction. So first of all, let's find out what the coordinates are for this vector. Looks like we've got a starting point of 1, 2, and we have an ending point of 4, 4. All right, let's draw that vector. Now, when we're talking about getting the angle in standard position, we want the angle relative to the positive x direction. So sometimes what I'll do is I'll create almost a secondary coordinate system here. Where the tail of the vector is at the origin. And that just shows me what the positive x direction is. Okay. Now we want to get the angle as measured counterclockwise from the positive x direction. So what does that mean? That means we would start here to the right of the tail, and then we want to start to measure the angle counterclockwise, and this is going to be the theta st, which stands for theta in standard position. Now, if we can find the horizontal and vertical components of that vector, we can actually use trig to find out what that angle is. So take this vector and draw its horizontal component. Okay. We also want to draw its vertical component, which could be drawn either here or here. So this is going to be delta x for the vector, and this will be delta y. So in trigonometry, if we know one leg of a right triangle, and we know the other leg of that right triangle, then these two have a relationship to the angle of that right triangle. The relationship here is the tangent of the angle equals the opposite over the adjacent. Now for our triangle, the opposite is going to be the delta y, and the adjacent is going to be the delta x. But when we do this formula, we don't want to put any negatives into it. And so for that reason, we're actually going to just use the absolute value of these quantities. Right now, both the quantities delta x and delta y will be positive, so it won't really be a problem here. But in some cases, it could become a problem. Now we want to solve this equation for theta. So typically, what you would do in trig, when you want to solve something like that, is take the arctan of both sides. Arctan and tan are inverses, so they cancel. And that will leave us with just the theta that we're looking for. Okay, so let's go ahead and find out what our delta y and delta x are for this vector. It looks like our delta y is going to be 2 and our delta x is going to be 3. So let's put those numbers in. We want the arctan, or the tan inverse, of 2 over 3. That's going to give us our answer here. Now you want your calculator in degree mode if you want your angle in degrees. You can put your calculator in radian mode if you want radians. I'm just going to leave it in degree mode. Okay, it gives me 33.7 degrees. And that's our standard position angle. So theta standard is 33.7 degrees. Now notice that this is counterclockwise from the positive x direction. (33.7 degrees counterclockwise from the positive x direction.